Welcome to the project demonstration of maximum demand control and fault alerting for industries. So here we are using PIC microcontroller for monitoring the load status by using this energy meter. And here the maximum demand nothing but whenever the load consumption was increase the threshold value. For example, we set the demand for around 100 or 150 watts through this switch, and when we set that particular wattage, then the system will continuously monitor the load status. If that particular load was increases this 100 watts or 200 watts, which was set from this button, then if it is more than that, the system will isolate the power supply to this load and provide us an audible alert through this buzzer and visual status displayed on this LCD screen. So the main purpose of this project is like when we are setting these limits, if the particular load was increases, then as you know that demand was more, then the power bill will be coming under the more rupees. So in order to eliminate that feature, we are going to control the power consumption in order to limit the load, in order to eliminate that maximum demand limitation. So for that purpose, we are going to use this energy meter, which will continuously measure the wattage of that particular load connected on this energy meter, and the energy meter reading will be continuously read by this PC817 optocoupler IC, and the output is input to the PIC16F72 microcontroller at A4 pin, and the status of the project status will be displayed on the LCD screen. We have interface at the pin number B2 to pin number B7, and based on the limitation crosses, when the threshold value crossed, then this electromagnetic relay isolate the power supply to the output load, and which was connected at the pin number C7 of our microcontroller. So this is acting as a switch between the power inputs and to the load. And when the abnormally detected, a buzzer will get switched on, which was connected at the pin number C3, and these two switches to set the threshold limits from the microcontroller. So in this one, we are providing 230 volts AC input, and which was connected parallelly to the energy meter and to this regulated power supply board, as it has the 4 stages: step down transformer to step down the AC to AC to 12 volts of AC, 230 volts AC to 12 volts of AC, and rectification to convert the AC to pulsating DC, filtration to remove the pulses to make the pulsating DC to pure DC, and regulation to make that 12 volts DC to 5 volts DC, as the operating voltage is 5 volts. Our microcontroller, when it get the 5 volts DC input, it start reading input from the switches initially. Once we set that, it will read the input from this optocoupler IC. So here, when we are going to calculate that based on this LED pulses, so when we know that when we connect a load to this LED will blinks. Based on the load, its blinking rate increases, means whenever the time duration between the two blinks is 1200 milliseconds, then that will be considered as 1000 watts. So that is a rating of our energy meter, means our current transformer which was presented inside this energy meter. So whenever the time decreases or increases, the voltage, the wattage will be varies. So as we said that the time duration between the two blinks is 1200 milliseconds, then it's considered as 1000 watts. If it is 2400, means once a blinks LED blinks, then microcontroller will start the timer, and it will count till the second blinks come to the picture. Between that two blinks, if it is 2400, then 500 watts of load was connected. So this is the calculation of this wattage. So let us see the demonstration. Once we on the power supply, a welcome message displayed on the LCD screen, and then it will ask for set the load initially. So just by pressing this, we can increase that. So as we have connected the 200 watts bulb, so let us place the limitation for 240, just for normal demonstration. So I'm setting that for around of 230, right? So when we press OK, then the bulb will get switched on, and the load will be calculated within 10 seconds of duration, and after that it will display the how much of wattage was connected to this energy meter, right? We can see that is 188 watts, and the set load was 240 watts. So everything is normal now. We are getting power supplied without any interrupts. Okay, so let us, if you want to change that again, this is a reset switch. To restart the microcontroller, just press and release. Again, next we will set this limit for low, 150 or 120 watts. Now okay. Right. It is 190 watts as we are using the 200 watts bulb and heavy load. That's why the relay got switched off. So you can demonstrate this with 100 watts bulb also by changing this limitation. Again, reset. So compulsory we need to set the load initially. We can connect maximum of 5 amp load, nothing but 1000 watts of load can be controlled through this electromagnetic relay. Here we can connect 1000 watts load maximum. So as of now for demonstration purpose we are using the resistive loads, which is the constant load. So if you want to demonstrate with variable load, then we need to connect the AC motor, which is where load varies based on the load applied on that particular motor. Right, you can see that 191 and this is normal. Right.